Hey guys, welcome to day 20 of 100 Days of Code. Today is really exciting because we're going to be using the knowledge that we've gained about object-oriented programming as well as what we learned about how to use the turtle module to build the famous Snake game. Now, this is probably one of the most famous mobile games there ever was, and it's definitely one of my favorite. And my history with it goes back all the way to my very first mobile phone, the Nokia 3310. I might be showing my age a little bit here, but this was my first ever mobile phone. And I remember loving it so much that I actually had it next to my pillow when I went to sleep. And this was probably one of the first affordable mobile phones, and it was endlessly customizable with different cases and different keys. But the most exciting thing about it was the Snake game. I would compare with my friends and see who got the highest score in Snake, and we would spend days and days playing this game. And compared to the iPhone games of today, of course, this was very, very simple, but nonetheless, it is still super addictive. Over the next 2 days, this is the game that we're going to build. A snake game that has a moving snake which you control using your keyboard, and it can go and get food, and then it grows in length as it eats more food, and you have to make sure that you don't end up getting tangled or hitting the wall, and the goal is to eat as much food as you can while staying alive. There are some people who are truly masters at this game, which I personally am not, but they manage to get their snakes to crazy lengths and start having these strategies for how you can avoid hitting your tail and how you can keep going. So once you've built your snake game, you'll be able to play with it and you'll be able to show off your high scores to the rest of us, but I'm sure you're going to do a lot better than me. It's not that hard to beat me at Snake. As always, when we're thinking about a complex problem, the first step is to break down the problem. And I'm going to break down this problem of building the snake game into 7 separate steps. And the way we're going to do it is we're going to tackle the first 3 steps on day 1 and the last 4 steps on day 2. So we're going to split up this game into 2 parts and we're going to tackle it over 2 days. The first step is to create a snake body. And we're going to do that by creating 3 squares on the screen, all lined up next to each other. And then we're going to figure out how to move the snake so that it continuously moves forwards, and all we have to do is tell it to change direction. Afterwards, we're going to figure out how to control the snake using keyboard controls. So we're going to be using the up, left, down, and right arrow keys to move our snake across the screen. And that is what we're aiming for by the end of today, day 20. On day 21, we're going to continue and we're going to build out the last 4 steps of the snake game. Then we'll need to start putting some food onto the screen and start to detect collision with the food, so that once the snake hits the food, then a new piece of food gets created randomly on the screen at some sort of random location. And then it's a matter of keeping track of the score and creating a scoreboard. So we're going to learn how to write text in our program so that once the snake hits a piece of food, the score automatically updates. And then next, we're going to figure out when the game should end. So one of the cases when the game should end is when the snake has collided with the wall. And at this point, we should see game over show up on screen and the snake should no longer move. And then finally, the other reason why our game could end is when the snake has collided with its own tail. So the snake basically can't chase its own tail, and as the snake gets longer, this problem is more likely to occur. And when the head hits any part of the body of the snake, then it's again game over. So these are the 7 steps that it takes to create the snake game. And once you're ready, we're going to get started with step 1 on the next lesson. So I'll see you there. So to start off, go ahead and create a new project called Snake Game in PyCharm. And then inside this project, we're going to create a new main.py file. And inside our file, we're going to need our normal imports. So I'm going to say from turtle import the screen class and also the turtle class. Now, the first thing we're going to do is we're going to create a new screen, which is basically going to be the window that shows up. And then we're going to set up our screen so that it is 600 by 600. So the width is going to be 600 pixels and the height is also going to be 600 pixels. And notice how I'm using these keyword arguments so that it's a little bit clearer to the next person looking at this code what's actually happening here. Now, the other thing I want to change is the screen's background color. So there's a method called bgColor, and inside here we're going to write the text black so that we end up with a black screen. Now, another thing that you might not have seen before is how to set the title of the window that shows up. And we do that through a method called title, and you can name your program here. So I'm going to call it my snake game, but you can of course call it whatever it is you want. Now, finally, at the very bottom of the file, I'm going to say screen.exit on click. So this way, when I actually run it, it doesn't just disappear straight away. And it waits for me and I can look at what's actually happened so far. So I'm going to click run and then select my main file. And once it pops up, this is what you should see, a 600 by 600 square window. And then at the top of the window, you'll see the name of your program, which is my snake game. And the background is now black. Now that we've set up our screen, we're ready to tackle the first of our 7 steps, which is to create a snake body. And we're going to create 3 squares, which are each going to be turtles. And they're going to be lined up next to each other along the horizontal axis. So let's think about this. When we create a new turtle, it has a dimension of 20 pixels wide by 20 pixels tall. And if we want 3 of them lined up next to each other, then we have to think about how we create their coordinates. As a challenge, I want you to think about how we can create this. Here we have 3 separate squares, which are each a turtle object, and they're shaped like a square, and they have a white color. Now, they're positioned so that the first one is at 0, 0, the next one is 20 pixels to the left, and the next one is again 20 pixels to the left, so that none of the squares overlap with each other, but there's also no gaps, so it looks like a whole snake. This is your challenge, and you might have to think about a few of the things that we've done before in order to achieve this. So browse the documentation, look back to the previous code that you've written, and see if you can solve this challenge. Pause the video now. All right, so the first thing we're going to need to do is to create some sort of turtle, right? So let's call this segment 1. And this is going to be a new turtle. And remember that when we initialize the turtle, we can already specify the shape. So we can either say shape equals square or simply just leave it as square. So now at this point, we should end up with a square turtle, but because it's black, when we run the code, we won't actually see it on screen. So let's change this segment's color to white. And all we have to do is write the word for the color. And now when we rerun our code, you can see a white square at the center, which is at position 0, 0. Now, the next step is to create our other 2 white squares. So let's go ahead and copy these bits of code, and I'm going to create 3 of them in total. So segment 2 and segment 3. Now here we're going to create the same thing, but we obviously have to change the positioning because otherwise we end up with 3 squares all on top of each other and we can only see 1 square because this is a 2D image. So let's go ahead and make segment 2 go to a different position. So the first thing we have to specify is the X, which you remember is the horizontal axis here. And And if we want another square to the left of it, then we're going to have to go to minus 20 from 0. That way it'll be shifted to the left by 20 pixels. Let's say go to minus 20, and then the y-axis is going to be 0 because it's not going to move up or down. Now let's take a look at the result of this, and you can see we've now got 2 squares lining side by side, but the third square is still at the center. So the third segment is going to be shifted a further 20 pixels. This is centered on 0, 0. This is at minus 20, 0. Then this has to be at minus 40, 0. So let's tell our segment 3 to go to minus 40, 0. And this is what we see. Did you manage to achieve this, or did you do it in a different way? Now, a much easier way of creating this would have been to use a for loop. For example, we could have created a list of starting positions, and this could contain some tuples. So we know that in order to specify where this segment should go to, we have to provide a tuple, which is a x and a y value. And we know that we can create a tuple just by using a set of parentheses and then adding values in there separated by commas. So if the first segment has to be at the center, then that's going to be 0, 0. And then the second piece is going to be at minus 20, 0. And the third piece is going to be at minus 40, 0. Now we can create a for loop. So for position in starting positions, let's loop through this list and create a new segment for each of those positions. So now we're going to create a new segment that's a square turtle that's going to be white, and we're going to get the segment to go to the position that we're currently looping on. Now we can delete all of that code, and when we run our code again, you can see we have the same effect. We have our 3 pieces. So if you can't remember how tuples work, be sure to go back to the lessons on tuples in day 18, where we talked about how to write them and how they work. But that completes our first step. We've managed to create 3 segments that will comprise our snake, and in the next lesson we're going to figure out how to get our snake to start moving by itself on the screen. So for all of that and more, I'll see you on the next lesson. In the last lesson, we managed to create our snake's body by creating 3 squares that were each turtle objects. Now in this lesson, we're going to move on to the next step, where we actually move our snake automatically across the screen without having to do anything. So this way, the snake is continuously moving forwards, and all we have to do as the user is just to change its direction. Now, how would we go about moving the snake? Well, we've already got these different segments that are created, but at the moment there's no way of organizing all the segments. They're kind of just created and placed on screen. So let's put them into a list called segments, and let's start out that list as an empty list, and then later on, once we've created each new segment, we go ahead and append it to this list. If we want something to continuously happen in our program, the way that we've usually done that is through a while loop. So let's create a new variable called GameIsOn, and let's set it to true. And while game is on, then we're going to move each of the segments. The simplest way that I could think of to move the segment is to loop through each of the segments in our list of segments, and then to get each of these to go ahead and move forwards. So let's say we move forwards by 20 pixels. Let's go ahead and run this program and see what we get. The first thing we notice is that the behavior is very weird. We've got a line that's being drawn, and that comes from each of the segments, which are individual turtles, and they're all drawing this line as they're moving. The first thing we want to fix is that line. So when we create each new segment, before we tell it to go to its position, let's go ahead and tell it to pull the pen up. This way it won't actually draw, and all that we'll see is the actual turtle pieces. So now we see our 3 turtle pieces scurrying along like some sort of weird caterpillar, but definitely not in a snake-like way. How can we fix this? One of the things that you notice about Turtle is it will first create the turtle. When it runs this line, the turtle will get created at the center position, so coordinate 0, 0. And then it will be moved to whatever position we tell it to go to. For example, for the 3rd segment, it starts out life at 0, 0, and then as soon as it gets told to go to this position, it goes to -40, 0. Now we can see that happening on screen. When we created our snake body, you could see each individual piece being created and then moved to their location. Now, if we wanted to turn off that animation, then we would have to use one of the screen classes methods called tracer. And tracer takes a number as a input, and it turns the animation on or off. And when the tracer is turned off, then we can use the update method to tell our program when to refresh and redraw the screen. When we think back to the old TV monitors, the cathode ray tube monitors or CRT monitors, the way that they worked is by painting on a strip of color line by line by line, slowly covering the entire screen. And then once it's done one screen, it's going to go back to the top and then it's going to paint the pixels for the next scene. And effectively, it's kind of like how a GIF animation works. A GIF animation is composed of many images. So, for example, if we wanted to animate, we would increase this line and then we would start drawing out a leaf until eventually we end up with an animation like this. Now, when that's all combined and played back very quickly, then this is the animation you see. In our game, what we could do is we could describe each of these scenes and tell our program when it should redraw each picture. So that way we could start out with one picture and then hit update and then do something else on screen, maybe move each of our segments and then tell the screen to update again to show the user the new result. And then each time we make the changes we want to happen and then call that update method to tell the screen to show a new image each time. Let's first turn off the tracer. So the tracer is a method in the screen class, and in order to turn it off, we're going to set it to 0. So now, once the tracer is off, if we actually try to run our program, you can see it's just a black screen and nothing will happen. Even though we've got our while loop and we've got our for loop and lots of things are meant to be happening, but until we call update, the screen is not going to refresh and it's not going to show us what's been happening in our code. So let's say that we decide to call update after all of the segments have been created. So right about here, let's call screen.update. And now if I hit run, you'll notice that pretty much immediately, as soon as you run the program, our snake body will show up, not piece by piece, but in its entirety. Now, if on the other hand, I move our screen.update line of code into the while loop so that once each segment moves, I get the screen to update, then this is what you're going to see. You see each of the pieces moving along one by one. Now, it's not really clear what's happening, so I'm going to slow it down a little bit. And I'm going to do this by importing the time module. Now, I'm going to add the time.sleep, and I'm going to get it to sleep by 1 second. So this basically just adds a 1 second delay after each segment moves. So each segment moves, the screen updates, and then we sleep for a second before the next time this happens. Notice how, in this case, our snake is moving piece by piece. So first this first piece, and then the second piece, the third piece, with a 1 second delay between each movement. Now, what happens if we move this screen.update to outside this for loop? So basically, we only update the screen once all the segments have moved forwards. Now, notice how our snake is moving forwards as an entire piece. It's going to move all 3 segments forwards before the update gets triggered and we refresh the graphics. So it looks like as if the whole snake is moving as one piece. Now, instead of getting it to delay by 1 second after each segment has moved, if I move this up here, then it's only going to be delayed by 1 second after all 3 segments have moved. This way, our snake is moving a little bit faster. And we can make it move faster still if we cut the amount of time that we're sleeping. So let's change it to 0.1 second sleep. And you can see our snake is now moving at a reasonable speed. Now, you might think that we've solved the challenge and we've now got our snake to move automatically forwards. But there's a problem. How do we turn our snake? Let's see what would happen if we control the snake head and change direction. Let's say that at some point we want to turn the snake so that it turns left. Well, what happens then? So this first piece is now facing up. The second piece is going to continue moving forwards, as does the third piece. Now, on the next iteration of that for loop, that first piece is going to keep moving towards north, while the second and third pieces are going to keep moving forwards because they're not going to change their own heading. We'll get this strange behavior because our snake segments are not linked. To illustrate this, let me go ahead and change the first segment, so the segment at index 0, and get it to turn left by 90 degrees. And notice when I run the code, you see how that head is moving in a circle all by itself, and the body has completely left the head and has continued to go forwards. So how can we solve this? Well, we have to rethink the way that we move our segments. Again, we have our 3 segments, but if instead of moving everything forwards, what if we get our last segment, so segment 3 in this case, to move to the position of the second to last segment, and then the second segment to move to the position of the first segment, and then the first segment itself to go forwards by 20 paces. And if we go back to that situation where we're trying to turn our snake, then in this method, it will still continue to work. So we've got our 3 segments, 1, 2, and 3. Our third segment goes to where the second segment used to be, second goes to where the 1 used to be, and then the 1 is going to turn and then move to the left. Now, the next turn is the interesting part, because at this point we saw how if these 2 pieces just continue moving forwards, they're going to move away from the head of the snake and it's going to move in opposite directions. But using this method, our third segment is going to move to where the second segment used to be, the second goes to where the first used to be, and the first continues moving forwards. This way, our snake has pretty much straightened out, as you would expect this snake to behave. Now it's just the matter of actually implementing this, which is the hard part. So I'm going to go ahead and delete the part where I told the snake to turn left. And I'm going to delete this for loop, which just moved each of the segments in our list of segments forward by 20 paces. Now, instead, what I'm going to do is I'm going to create a for loop, but this time I'm going to loop through each of the segments going from the last segment to the first segment. So basically in reverse order. Now, to do this, I'm going to use the range type of for loop. So I'm going to say for segment number or segnum in the range, and this range is going to have a start, a stop, and also a step. So the start is the number that we're going to start the range from. The stop is where the range is going to end, and the step is how we're going to get from the start to the stop. For example, if we wanted a range of 1, 2, 3, then of course start is going to be 1, stop is going to be 3, and step is going to be plus 1. Now, if we wanted a range of 3 to 1, however, then the start is going to be 3, the stop is going to be 1, and the step is going to be minus 1. In our case, what we actually want is actually to go from 2, 1, 0. So the start will be 2, the stop will be 0, and the step will be minus 1. Now, unfortunately, even though we have these named parameters, because the range function in Python is actually something that's not quite pure Python, it's something that comes from the C language, it doesn't actually let us use these names. I'll show you when we run our code, this is actually going to give us an error. But for the time being, it's actually much easier to visualize this as we write the code inside this for loop. So in this case, the segment number is going to be equal to 2, and then 1, and then finally 0. Now we're going to use that to get hold of the last segment from our list of segments. So we can tap into that list and then get hold of the last one using that seg num. And then we're going to set it to go to a particular X and Y position. Now the X and Y position that we want it to go to is going to be the second to last segment's position. So how can we get hold of the second to last segment? Well, we're going to get hold of the segments and then pass in segnum, but then minus 1. So when we first start out, we start out with 2. So the segment at position 2 is going to be the last segment, and then the segment at 2 minus 1 is going to be the second to last segment. Now this one, we're going to get hold of its X coordinate, and we're going to set this to a variable called new X, and then we're going to do the same and get hold of the new Y. So we're going to get hold of the second to last segment's Y coordinate, and then we're going to use these coordinates, new X and new Y, to tell this last segment to go to the position of the second to last segment. Now, as I mentioned before, this range function comes from the C language. So if we run it with these keyword arguments, it's actually going to give us an error, and it tells us that this range function takes no keyword arguments. So while it's really nice to use it to visualize it, if we actually want it to work, we have to delete these. But just before I delete it, I want to change this so that we're no longer using these hard-coded numbers. So instead of going from 2 to 0, we want to go to the length of these segments. So in the future, if we had 10 segments or 20 segments, that our code would still work. Now the length of the segment is actually 3 to begin with, and we know that lists start counting from 0, so 0, 1, 2. The last position is going to be the length minus 1. And then we're going to stop at the 0th segment. So now we can go ahead and delete these named arguments. And we end up with this. And now we can run our code and we won't get any errors. Notice how all 3 of the segments went to the same position, the position of the first segment. So in addition to moving these segments, remember that we also have to move the very first segment actually forwards by, say, 20 paces. So at the very end of all of this code, outside of the for loop, we're going to get hold of the first segment, so segment at position 0, and then we're going to get it to move forwards by 20 paces. So now when I run this again, you can see our snake is now moving freely forwards. And even if at some point the snake needed to turn, let's say it turned left by 90 degrees, then our code is still going to work. Notice how our snake is now turning in a circle, and all of the subsequent pieces are following the head along its path. That's it. This is the code that will get our snake to automatically move forwards. Now, there was quite a few concepts mentioned in here, and you have to think about the segments in terms of how they move in the graph, and also this idea of getting hold of the last segment and then telling it to go to the position of the second to last segment, and then doing this for all of the segments. So it's a little bit mind-bending, and it might be worth just taking a second look at this code and going back in the video where I explained how this worked in the slides, just so that you're really clear with how this works. Once you are, then you can move forwards and head over to the next lesson. So far, we've managed to get our starting segments for our snake to appear on screen, and then we managed to get our snake to automatically move forwards and to figure out a way for the tail of the snake to follow where the head is going. Now it's time to tidy up our code a little bit so that all the parts that are related to the snake's behavior and the snake's appearance go into a separate class. So that by the end of the whole project, we should end up with 3 classes: a snake class, a food class, and a scoreboard. And all of these classes will be in separate files managing only one thing. And the goal of the refactoring is so that you could create a separate file, snake.py, import the snake class that you've created in that file, and then once you initialize the snake, it will do everything that we have so far and create our 3-segment snake onto the screen. And then finally, while the game loop is running, we're going to get the snake to continuously move forwards just by calling snake.move. This is what you're aiming for. Have a think about how you can take the existing code that you've got in the main.py and extract all of the snake related functionality into a separate snake class and make your main.py end up looking like this. The program should do the exact same things as before. The only difference is how the code is organized. Have a think about this. You might need to revise some of the things you learned about how to create classes, how to create objects from the previous lessons. But pause the video. I want you to give this a good try before you come back when we'll go through the solution together. Alright, so the first thing we need to do is, of course, to create our snake class. And remember that in Python, class names are in Pascal case, so the first letter needs to be capitalized. And then inside this class, I'm going to create my init. Now, the code in here is going to determine what should happen when we initialize a new snake object. So firstly, I'm going to take these starting positions and take it over to our snake.py. Now, I'm actually going to put this in as a constant, so right at the top. And remember that in Python, the constants are named with all caps like this, and also with snake case with underscores separating each of the words. Now we can use these starting positions inside our snake class to create our new snake. So we're going to need to move our segments over as well. So let's create a new attribute that's associated with our snake class called segments. And remember, we're going to need to use self when we're working within a class. After that, we're going to create our snake. So I'm going to create a method called createSnake down here. And this method is going to do everything that we previously had over here, but we're going to move that into this method. Now, there's a couple of things we need to change. Firstly, we changed these starting positions into a constant, so let's make that consistent. Second thing is that we need to import turtle into this file from the turtle module in order to use it to create a new segment. And then finally, in order to refer to our attribute segments, we have to say self.segments and then append this new segment to our snake segments. That's this part done. The next thing we need to do is to get rid of this code and move it inside the snake. So again, I'm going to create another method that's associated with the snake class called move. So when the snake moves, it's going to look to this code to figure out how it should do that. Again, because we're inside our class, it's no longer just segments. It's now self.segments. So let's go ahead and replace it in all the places where we have our red underlines. And now that's pretty much it for our snake class. We can create a new snake object, and each time we do that, it creates a 3-segment snake using the starting positions, which are declared at the top. So if we want the snake to show up on screen, then we're going to have to first import the snake class from the snake file, and then we're going to create a new snake object from that class. And once this line gets triggered, then we're going to be calling create snake, and our 3-segment snake will show up on screen like this. Now, the next step is while the game is on, the screen is going to update every 0.1 second. So that's essentially what this is doing. It's saying that delay for 0.1 second and then refresh the screen. And every time the screen refreshes, we're going to get the snake to move forwards by 1 step. Now, at the moment, each step is defined here as 20. So again, I want to extract that into a constant up here. So we're going to call it the move distance. And we can set that to 20 and then change this to use the constant here. And the reason why we have all these constants is so that if we wanted to tweak our game, say if we wanted the snake to start at a different position or for it to move further each time, then we don't have to dig through the body of our code. All we have to do is look at the top, look at all the things that we can change, and then change it accordingly. So now coming back to our code here, all we now really have here is just these few lines of code. And everything that is snake related, creating the snake or moving the snake, is now abstracted into its own class. This way, when something goes wrong with our snake, we know who's responsible and which file to dig through to figure out the reason. Now, at this point, if we go ahead and rerun our code, you can see that our program works exactly the same as before. Nothing should have changed and nothing should have broken. Now, because our game isn't yet able to go into the game over sequence, there's no way of stopping the snake other than hitting the stop button. So don't worry if at this stage inside your console you see a lot of red and it says things like keyboard interrupt or traceback errors. All of these are normal. The thing that you're more concerned about is whether if when you run the game, whether if it actually works like it used to. So namely your snake moving across the screen. If it does exactly what it used to and your main.py is now much simpler and all of your snake functionality and behavior and appearance is now inside its own class, then you have successfully achieved the goal of this lesson. So we've now managed to create a snake body, move the snake, and we've even managed to put our snake related code into a separate class. Now, the next step is to figure out how to control the snake. Now, we're going to control the snake by using the up, down, left, and right arrow keys. And we're going to be using our key bindings that we learned in yesterday's lessons to be able to translate this into a change in direction of the snake. In our code, right after we create our snake, we're going to call the screen.listen method to start listening for keystrokes. And the keystrokes that we're going to listen for are the up, down, left, and right arrow keys. Now, those keys are described by a string. So it's a uppercase U and then a P. So this would be up, and then it's again uppercase down, left, and right. These are the keys that it will detect. Obviously, the up, down, left, and right arrow keys on the keyboard. The function that you're going to bind it to is going to be a function in the snake object, and it's going to have the same name. So for example, it will be snake.up, and that will be triggered when the up key is pressed. And then the same thing happens with snake.down when the down key gets pressed, and then again with left and right. Your job is to have a think about how you can create these methods up, down, left, and right in the snake class so that when the up key or the down key is detected, you can move the snake and change its heading accordingly. So remember that up is going to be towards north, down is going to be south, left is going to be towards the left of the screen, and right is going to be towards the right of the screen. So have a think about the headings that we spoke about in previous lessons. And if you need to, it might be worth just setting up a brand new project, getting a turtle up and running, and then setting its heading from 0 all the way to 360 just to see which direction it's actually facing. If you manage to complete the challenge, you should be able to control the snake, and even though it's going to continue moving forwards, you now determine which direction it moves in by using the arrow keys. Pause the video now and see if you can complete this challenge. Alright, so I've already created all of these lines of code, which is going to get the screen to listen for these keystrokes. And then when it detects it, it's going to call these methods in the snake class. So inside our snake class, let's go ahead and create those methods. So we've got up, down, left, and right. Let's think about how we can turn the snake up. In order to turn the snake, the segment that we're most interested in is the first segment. That's basically the head of the snake. So we could tap into self.segments and then get hold of the 0th segment, which is the first one, and then change its heading by calling set heading. And then we can tell it to, for example, if it's up, then it should actually be turning to the 90-degree direction, which is actually towards north. Now I'm going to go ahead and put a pass on all of these other methods, just so that we can actually test our code and it doesn't give us any errors because these functions are currently empty. Now, if you don't have the pass, it won't like it because Python doesn't like the idea of empty functions. But now we can at least just test this one thing. So when we run our code, we should be able to hit the up key and you can see the snake change direction. Let me just do that again. And this is because we managed to get the first segment, the head of the snake, to change its heading to 90 degrees, and then the rest of the body will follow because it's continuously moving on every tick of the clock. So using this, we can now set the rest of the methods. But because we're going to need the head of the snake quite a few times in our code, it might make sense to actually create a separate attribute. So after we've created the snake, after we've got some segments inside this list, we can create an attribute called head, which is going to be the head of the snake. And this can be equal to self.segments at index 0. Now remember, if you have this line of code above the create snake, it's probably going to error out because at this point the segments is empty, and if you try to get the first item from it, it's not going to allow you to. So look at the positioning of the code here. Now once we've got this set, we can go down here and change everywhere where we need to use the head of the snake. So for example, when we're moving the head forwards and when we're moving it up, left, down, and right. Now we can set each of these headings. Up is going to be a heading of 90, down is going to be 270, left is 180, and right is 0. These directions are just simply counterclockwise. So the turtle starts out pointing towards east, and that's a heading of 0, and then going anti-clockwise, up is 90, left is 180, down is 270. This can be easily verified just by testing out some numbers, right? You could just put some numbers in there and then just try it out and see which direction it goes, and then you'll be able to figure it out. But we've also mentioned this in previous lessons, so you could also go back and take a look at when we looked at the heading of the turtle. So now if I go ahead and run this, then you should see that I can now freely control the snake by going left or right or down or up. And if you manage to do this, then you should consider yourself successful. Now, while I was testing this code, I realized that there's something about the snake game that we haven't really accounted for. And it's the fact that the snake can't move back on itself. It can't go forwards and then go the opposite direction, because that requires the head to change directions. And this is not allowed in the official snake game. So how can we code this into our game? Well, we have to figure out when the head is pointing towards down direction, then we shouldn't allow it to go up. And similarly, when it's pointing up, we shouldn't let it go down. When it's pointing right, we shouldn't let it go left. So at the top here, I'm going to create some constants. I'm going to create a up direction is going to be 90. Down direction is going to be 270. Left is going to be equal to 180. And right is going to be equal to 0. So now that I've got all of these as constants, I can go in here and set the heading to instead say up when it needs to go up, down, left, and right. In addition, we're going to do an if check. So we're going to say if the current self.head.heading is not equal to down, well, in that case, it's allowed to move up. So this way, it just means that if the current heading is pointed down, it can't move up. But for all other directions, if it's already moving up or left or right, then it can change the heading to up. Now, be really careful here because it's not just self.head.heading, it's actually heading as a method. Because remember that the head of the snake is the first segment of our list of segments, and each segment is an individual turtle. The turtle has a heading method which will give you a direction in terms of these 360-degree numbers, and then we can use that to check to see if it's equal to down, and if it is, then it's not allowed to go up. So using this logic, see if you can complete the rest of the three methods so that when you run your code, you can turn in all directions. But when you're facing one direction, you can't go backwards like this. All right, so it's going to be pretty straightforward. If it's already going up, then it's not allowed to go down. If it's already going right, then it's not allowed to go left. And finally, if it's already going left, then it's not allowed to go right. So this way, even though our snake can move freely through the space, it can't go back on itself. And there we have it. We've now managed to create our snake, get it to move, and control it using our key presses. Even though it seems like our game is still not quite there, we've already come so far. So this comes up to our hour mark, and it's now time to take a break, refresh your mind, look at some of the concepts that you might be confused about that we covered today, especially this concept of using the update to refresh the screen, as well as using the timer to delay the refresh so that we can control how often it happens, and then using our key bindings, as well as separating our classes. We looked at a lot of things today. Now tomorrow, once you're rested and fresh and ready, we're going to be finishing up the snake game. And we're going to be learning about inheritance as well as slicing. And we're going to be building out the full functionality of this game. So I hope you're looking forward to it. I certainly am. I'll see you tomorrow. Hey, you've reached a big milestone. Today, you've completed 20 days of code. Now that is a fifth of the way, and that's massive. If you're not already, you should be really patting yourself on the back because you've done really well. Now, today the thing I want to talk about is a question that students often have, which is, hey, I've gotten to day 20, but when I look back at the stuff that I did on day 1, I can't remember exactly the names of the functions or how to write out the syntax for a particular piece of code. Does that mean that I haven't learned anything? And the analogy that I like to give is, have you ever played video games? Especially video games where they require like complex combinations that you have to remember, like Street Fighter? You know how in order to do like a particular move, you need to be able to do up, up, down, down, X, Y, A, B. Now, when you're doing it in that moment, when you've just learned it, you remember how to do it. But when you come back to it in a month, you're like, oh, I don't remember those combinations. Does that mean that I haven't learned anything? Well, the point is that programming is not about memorizing, because we're in a day and age where information is cheap. You can search Google for any piece of information you want, and it's there within a second. What your job needs to be is to understand how things work. Make sure that you understand how to use the code, when to use it, how it works behind the scenes. That way, the next time when you need to use it and you've forgotten how to write the syntax, you can just Google it, look it up. And as soon as you see it, you'll remember, oh yeah, that's it. I know how to use it. So don't worry about memorizing things. Focus on understanding the code. So good luck and keep going.